Infinity? Sounds huge, right? But what if I told you there's not just one infinity? There's a whole of infinities. Some infinities are so big, the normal ones look puny by comparison. Grab your brain because things are about to get wild. Let's start with the smallest infinity out there, the counting numbers 1, 2, 3, 4, and on forever. I can list them one after another for as long as I want, even if I throw in negative numbers or fractions like 1/2 or 7/5, I can still arrange them in a list. So mathematicians call these countable infinity. You can, in theory, match every item to your fingers if you had enough time and enough fingers. But now, let's crank up the weirdness. Let's look at every possible decimal between 0 and 1. That's numbers like 0.123, 0.56789, 0.999. You get the idea. You might try to list them, but here's where the universe cracks open. Imagine you make a list. First row 0.1234, second row 0.5678, third row 0.3141, and so on. Now I can create a sneaky new number by grabbing the first digit from the first row, the second digit from the second row, the third from the third, and so on, then changing each one. So if the digits are 1, I make it a 2. If it's a 5, I make it a 6. Build a number this way, and it won't be on your list because it's different from every number, at least in one spot. Boom! No matter how you try, there's always a number you miss. That's Cantor's diagonal argument, and it proves these decimals are a whole new level of infinity. Let that sink in. There are more decimals between 0 and 1 than there are whole numbers in the entire universe. Seriously, there are more of these decimals than all the integers, fractions, and even prime numbers combined. Mathematicians call the countable infinity a left null, the smallest infinity written as 0. But the infinity of the continuum, the real numbers, is even bigger. That's right, some infinities are just hugely, mind-bendingly bigger. Why should you care? Well, this is why computers can't crunch every problem. It's why black holes might hide infinite information. And it means mathematically that there are things that can be listed or counted even in principle. Infinity isn't just big, it's wild. So what do you think? Is your brain melted yet? Drop a comment. Mind blown or Cantor is wrong. Don't forget to like and subscribe. Math isn't magic, it's everywhere.